Hello everyone. As usual, today I'm going to explain something. It's about density. It's one among the very common topic, very familiar topic. What is density? Density it means that the mass of substance per unit volume. Density is affected by two main factors. The first one is mass, and another one is volume. When the mass is higher, it means that the density of substance increases. When the mass is low, it means the density of substance decreases. When the volume is higher, it means that the density of substance decreases. But when the volume is low, it means the density of substance increases. So our goal today is here I will discuss the following: density, mass, and volume. So our goal today is to understand how the concept of density relates to an object's mass and volume, how objects of similar mass can have different volume, and how objects of similar volume can have different mass. Explain why changing on an object's or volume mass does not affect its density. That is, understand density as intensive property. So let's start. So the first part is here we need to see the effect of mass and volume to the density. Let's assume this is our media, for example, water. The first here we have different material. Let's start with styrofoam. Styrofoam has less mass but large volume. So if we take this one into this water, let's say, do you see it floats, but the very small part of this styrofoam sinks. It means that the density of styrofoam is less. Now let's change to another material, wood, for example. Wood, it has less mass also than its volume. It means the density also is less. That's why most of the parts is still floating, but the amount of sinking has increased compared to styrofoam. Let's go to the third material. Let's say icy. Icy, it has the mass is increasing. As the mass increase, density decrease. As the mass increase, density increase also. Due to that, that's why it sinks. Very small part of the icy is floating. Now let's change to another material. It's called PVC. PVC, it sinks completely because its mass is higher than the volume. So the density is higher than the density of our media. If you go to another material, let's say brick, which one else? Aluminium. So the mass is increasing while the volume is decreasing. Due to that, the density is increasing and the volume is decreasing, and that's why the density is higher than the density of the material. So this was the first task. The second task is we are supposed to check, for example, now we have material of the same mass. Will this affect the density? So this material have the same mass, but the problem is their volume of different is different due to their shapes. Due to that, it means that, for example, this one it has large volume than this one because of the shape. Due to that, the density is less than the density of this one. Let's drop this one. You see? And then let's drop this one. This one, it sinks than this one. Why? Because this one has large volume due to its shapes than this one. So that is the second demonstration. Let's assume same volume, for example. This material have different mass but same volume. Volume is constant. But their mass is high. It means, for example, this material, its mass is 80 kilogram. It means that its density will be higher than the density of this. This one, it will float more. This one, it will sink more. And this one, it will float more. Let's drop it. You see? Because its volume is, its mass is very less than the mass of this. Let's drop this one. You see? Let's assume same density now. What does it mean when I say same density? Doesn't matter material, they have different mass, different volume, but if they have the same density, it means that their density is constant. It will have no effect. Drop this, and then let's drop this. Same thing. Let's drop this one, and then let's drop I'm going to explain. In the last two work, I explained about the density and what factors affecting density, mass and volume. As mass increase, density increase and vice versa. As the volume increase, density decrease and vice versa. The second work, I explained what happens if two materials will have the same mass, two materials will have the same volume, and two materials have the same density. So now we're going to explain about the bending of light, and a very important part is called refraction of light. Refraction of light is guided by the principle, it's called Snell's law, which states that n1 sine theta 1 is equal to n2 sine theta, sine of the angle 2. So let's assume here now we have one material which is air and second material which is glass. Less denser medium to higher denser medium. It means that the light will bend towards the normal mostly. Let's click it here and see. For example, you see this is our light, incident light. This is our normal line, and this is a refracted ray. But if for example, material, where is it? Let's try another material, say glass, which is 1.5. The same thing, it's bent but near the normal line. But if material will move, the light will move from the media of higher density to the media of lower density. For example, from water to air, it will bend very far away from the normal. So that's like you can see it from here. So this is one among the very important topic, which is refraction of light. So I explained three works. The first one is density and what factors affecting density. Second one, what happens if materials will have the same volume, same mass, as well as same density. What are the effects towards it? And the last one is bending of light under the Snell's law.